Guten Morgen. So I'm here with good news, because we will all be game programmers very soon. So I'm sure a lot of you, like myself, kind of got into programming in the first place because you wanted to build the next Mario. In the decades since then, it turns out I build a lot more banking apps than Mario. But I'm excited that JavaScript is heading in a direction where we're all going to be able to integrate a couple of things from video games into all of our apps very soon. So not only do I think these techniques are useful, that we can get from game development patterns, I actually think they're inevitable. So no matter what you do, you're going to end up integrating at least a few of these things in the next couple of years. So this might make a little bit more sense if I explain my double life. During the day, I'm the node guy at Heroku, right? So whenever any of you file a node ticket at Heroku, it goes to me. And whenever the build pack doesn't work, I get yelled at. And whenever people are confused about the Dev Center documentation, that's also my fault. So I'm sorry. And this is sort of like my serious work. This is the work that I do that people's livelihoods depend on. And so it's kind of the scary, slow development work that I do from 9 to 5. But it's also really interesting because it's the first role that I've had where there are literally thousands of production apps that people are earning a living with that I can look at and I can compare how people are following different patterns and how some companies are successful while some aren't. There's actually a really interesting talk later today about how Toyota Europe is going to be is running right now on Heroku, and that's by Ray McDermott. You should check it out. So anyway, I've gotten sort of a unique insight into how people are building JavaScript apps these days because I see so many of them every day. And that's my day job. At night, I work in a less serious way. I work on something I like to call playful JavaScript, right? It's JavaScript that doesn't really have a purpose or a point. It's a JavaScript that's JavaScript techniques that aren't going to help you pass questions when you're interviewing for a job, right? It's nothing that people teach at university. But it's the stuff that I've been interested in since I was a kid, right? It's like games, graphics, audio. I play with things like procedural generation. I play with stuff like old school 3D rendering techniques, right? And then occasionally, very occasionally, some crazy company will pay me to build a game in HTML5. And this is becoming a bigger and bigger thing, right? A couple of years ago, this would never have happened. Nobody would ever reach out and say, hey, can you build me a game in JavaScript? So I'm really excited about this, and I think this is just going to keep on accelerating. So I wanted to just highlight that because this is the basis for the talk, and I'm not an expert, right? So I just play with things at night. I am an expert at Node and running production Node apps, but this is just my hobby, and I'm not a game developer by trade, but I love this stuff, and I think that more of us are actually going to become game developers by trade over the next couple of years. And even if not, it's fun to learn, right? And it's something that I think everybody should try at least once. So first, why should JavaScript developers even care about what game developers do, right? It seems like we're worlds apart. They write things in C++ while we write in an interpreted language. They're writing on bare metal, whereas we're trapped in a browser, and they're concerned with players while we're concerned with users, right? So it doesn't seem like there's a whole lot of overlap here. To answer that question, let me take you way, way back to 2008. That was back when jQuery was also still new and popular with everybody. And this is Google Maps in 2008. As usual, Google is pushing the limits of JavaScript, so this was a cutting-edge app. But from our current perspective, you can see that it was just a little bit better than MapQuest, right? It's still two-dimensional. It's still very simple. There's not a lot of interactivity here. Now, here's 2008's Grand Theft Auto. It's the exact same year, but a very different piece of software, right? Instead of a 2D top-down camera, you've got a 3D moving camera, you have full textures and full shadows, and even the geometric detail on the buildings is sort of incredible. It's a far cry from the Google Maps of the same era. Okay. But 4 years later, Google released an update to Google Maps. And in this new version, you have the 3D textures, the geometric detail, the dynamic shadows, right? And that brings me to the question, if you had to put some money on which one of these three apps is most similar, which two of them have the most similar architectures, which would you bet on? My money would be on these two. So even though it's the same app, the Google Maps of 2013 is a lot closer to a video game, Grand Theft Auto of 2008, than it is to its predecessor. Similarly, in 2004, Nintendo's DS Touch was a big hit. Early developers for the platform kind of pioneered what touch can do as a core interaction element. And then in 2007, the iPod Touch was also a big hit. Apple is clearly responsible for the fact that nobody younger than me even knows how to use a screen that you can't, touch and drag things on. But even though Apple's responsible for making it ubiquitous, touch was really pioneered in the games industry. And do any of you remember Moon Patrol? Really? All right. What? Wow, well, congratulations, because I was 1 year old when this came out, so I don't remember Moon Patrol. But according to Wikipedia, it was the game that pioneered parallax, right? So as you moved, the backgrounds actually scrolled at different speeds relative to each other to give you an illusion of depth. So this was the first game, at least according to Wikipedia, to use that. And now you can't go anywhere without seeing parallax on some website. You can't throw a stone without hitting somebody who's stuck parallax on their site, sometimes for good, sometimes for bad. You know who you are. And I just think it's incredible, though, that something decades ago that became prevalent in games is just now gaining popularity in the web. And this is sort of a trend that we see over and over and over, that games sort of lead all other technologies and kind of push boundaries that we then come in and get to fill once it's easier to do. So today's game experience leads to tomorrow's app experience. And this is important because that means that if you want to know how to build the apps of tomorrow, you should be looking at what games of today are doing and how they're working and what kind of technologies they're employing and how they're training users to expect interfaces to behave, right? So you can see a lot of other examples. I've given several, but every time you use Google Docs, you're now sharing an interactive virtual environment with other users, and this is something games have been doing for decades, but now document services are starting to do it, and it's like a big deal, right? So it's important for everybody to learn. Of course, I'm not the first person to realize that we can learn a lot from game developers. If any of you have been getting spammed by Famous like I have, you know all about it. But it's basically a game engine that allows you to run apps on top of it, right? So they just chucked all the regular MVC framework stuff out the window, and they were like, we're going to build I think they called it a crappy game engine, right? And that's what people are running really interesting interactive apps on top of with great success. And then this is my favorite example of how sort of games and apps are colliding, at least in JavaScript. This is the architecture for Doom 3. So the important part is actually the second and third step. The second step, the scene IR, this is where Doom actually builds a description of the scene. It figures out what you're looking at, what you can see, what's in the frame, what's local to your character. And then the fourth step is where it actually renders it. And this is the expensive step, right? Rendering something in 3D costs a lot. And the operation order and which operations you choose to render are actually really, really important. They can make your frame rate fast or they can make it slow. And so in Doom 3, they actually figured out exactly which operations they needed to pass to the renderer before they rendered anything to make the application run as quickly as possible. And this is what I think is really fucking cool. React.js, the library that you guys might have seen from Facebook, actually works the exact same way. The architecture is identical, right? And so instead of OpenGL, though, their bottleneck is the DOM. And so they build sort of a scene. They do like a full scene builder before they run to the DOM, and that way their scene builder can compute exactly which DOM operations would be fastest to render. So they're pulling ideas straight out of the world of game development. So it's inevitable. You're probably already using some of this stuff today. And if you're not, then I guarantee it you will be. So I think that this is a great opportunity to sort of become familiar with some of the patterns that game developers have been using for decades, so that when you're building your next app, you can at least have them in your tool set. That's the argument for using game techniques inside of apps. But of course, the other reason you might want to know about game dev is because you just want to build a game in JavaScript, right? And I've got great news for you. There's never been a better time to build games with JavaScript. Finally, we have all the basic primitives we need in the form of web APIs in order to start competing toe-to-toe with real native experiences. The gap between JavaScript and native capabilities is closing rapidly, and I'm really excited about this. So that begs the question, why isn't everybody doing this? Well, some people are trying. Some early pioneers are getting out there. This is a game called PollyCraft. It's a really polished 3D game built in JavaScript. And then, of course, you've probably seen Cut the Rope, which is probably the most well-known HTML5 game to date. But there's not a whole lot of examples, and there's not a whole lot of success stories. And the reason is because that we lack familiarity, tooling, and a marketplace. Game developers have a huge tool set, and they have familiarity with how games are built. They also have marketplaces with which to ship games. We don't have any of these things. And certainly I can't address all of these today. What I'm going to try to do is provide a little familiarity to a group of JavaScript developers who might be interested in building a game someday. So with that, we're going to start looking at a couple of very basic game dev techniques. And these are things that you're going to use any time that you're going to build a game in any language. We're going to look at it specifically in JavaScript. And all of these techniques can also be applied to apps these days, which is really neat. It usually takes a little more creativity to do that, but they can push things forward. So the first pattern to look at whenever you're getting into game development is the game loop. This is the basic, core, fundamental idea behind any game that's ever been written since video games were a thing, right? And it's the sort of code that you probably would not get through code review at most shops, right? It's just a while loop that never stops, and it has some conditionals in it, and you're just doing everything in like this sort of waterfall pattern. But this is what's powering every game that you've ever used. And the reason for that is because it makes time explicit, right? The issue with traditional event-based architectures that we're all using in our games now, where you have an event, like a click event, and that event triggers some kind of reaction, like maybe you closed a window or you moved to the next screen, is that time is implicit in that, right? Like an event happened, and then you gave a response. And so you know that the response happened after the event, but you never elevate time to a first-class citizen. You never measure time to the point where you could actually put it into a variable. And that's what an event loop, or that's what a game loop gives you. It lets you measure time between different iterations of your loop and store time into a variable. The other thing that it lets you do is keep moving without user input, right? So if you don't have a game loop, if you're just responding to events, then you're dependent entirely on the user to push your game forward and to push any elements on the screen forward. And with a game loop, you can actually respond to time instead of to the user. So you don't just have to have an action and reaction sort of pattern. And I actually have two demos that I hope will work to sort of illustrate this. So let's go here. So this is a version of a small, simple game. And I hope it doesn't blow anybody's ears. Let's get a little quieter. This is a small, simple game without an event loop, right? So this is a game that only runs with there's no loop here. It's just listening to my input, and then it's responding to the input, right? So like if I start pressing keys, then it'll like start doing things, right? And I can move around, and I can jump, and whatever. But then as soon as I stop, nothing happens, right? So I could be in the middle of a jump, and it's just there, right? So if you tried to build a game using MVC, if you tried to use Backbone to build a game, like this is basically what would happen, right? So you're entirely dependent on the user for everything in this environment, right? So as soon as the user stops doing anything, your game is sort of pointless, right? And this is not just true with games. This is also true with anything that requires physics and motion beyond something that you're responding to, right? Anytime that you see like a bounce effect or a nice physical scroll, or when you flick an icon and it moves with momentum, right? It's got the same problem. So that's without an event loop. And then if you go with an event loop, this is the exact same game, but it's just going to keep running no matter what, right? So I can stop doing anything, and everything still works. I'll still fall, everything behaves, the environment's still going to be alive, right? And this is 100% due to the event loop. There's literally no other difference between these two games. I copied and pasted. So So that's how important an event loop is to rich, interactive, dynamic applications. So let me kill that so the music stops. And then, cool. So once you've got a game loop, you quickly run into a problem. And the problem is that you're starting to pack all of the logic and stuff for your game into this one loop, right? And you can imagine how that gets really hairy. Once you have more than one or two different entities that you're trying to update with time, they start to sort of get conflated. You've got this like enormous, 1,000-line loop, and you don't know where anything is. So in almost every game that's ever been created, there's an update pattern, right? And this is where you make your game entities, or even just your graphical entities, autonomous. You teach them how to handle their own changes through time, right? And you can see here, it's just an organizational pattern. You're not really doing anything differently. You're just organizing it in a sane way. And this is important because that way your player can know how to walk and how far he needs to walk depending on how much time has passed. Your clouds can move with the wind. And when you flick an icon, right, that icon knows how to keep sliding across the screen without any sort of direction from the main game loop. And so, we all know that decoupling is a good idea, and this is one of the primary ways that decoupling is done in games that have to respond to time and not just to the user. The other cool thing about it is it's sort of like a light form of dependency injection, because you don't have to just pass time to these things. You can also pass other arguments that they may depend on. And then the final thing that you need to know if you're going to just ship a game tomorrow is you need to understand what a time buffer is. A time buffer is an extension to the traditional game loop and update cycles. And what it does is, instead of treating time in each loop as an individual entity that you respond to, it actually, every time you get a new instance of the loop, you add time to a buffer. You just keep packing it into a buffer. And then whenever that buffer overflows a certain amount, which is your frame time, you render a frame. Right? So you just keep on adding to the buffer, and whenever the buffer is bigger than a certain set amount that you decided on initially, you render a frame and you clear that time out of the buffer. This sounds like you might be overcomplicating things, right? Because you've already got a game loop that will let you process time. This is important for a couple key reasons. The first is that it keeps physics models stable. If you don't do this, most physical integration methods, from the ones that you see on your iPhone when you pull down the drawer to the ones that you see in a 3D video game, will sort of start to feel weird and wonky because they're rendering at different time intervals. So sometimes you're moving a character really far, and sometimes you're not moving it far enough. So it's really important for anything that has physics involved. But it's also important because it decouples simulating and rendering. And this is critical for JavaScript developers, because you're going to want to use request animation frame anytime you're building anything that you want to be responsive on the web. And with request animation frame, you know that the browser is ready to re-render the DOM, but that might happen at 30 frames per second on one machine and 60 on a different machine. But you want those machines to be able to simulate the exact same thing at the exact same speed. A time buffer will allow you to do this. A time buffer will make sure that both of those machines call the update method with the same amount of time over and over and over, and the output, the result of both machines will be the same, even if they render a different number of frames. And this is kind of hard to explain, so I've put together a little demo of it. One of the stupid side projects I work on is called Newton, and it's a physics engine that no one should ever use, because I just wrote it to learn how physics engines work. And one of the things that I discovered was that it's really cool when you can replicate time-based behavior. And that's what a time buffer allows you to do. No matter how many times I rerun the same physical simulation, it'll happen the exact same way every time, which means that you can write automated tests about it. And this is really important when you're trying to use game techniques in an app, because you obviously want to write automated tests for your app. So let me open up this example. All right, so this is Newton. It's a little embarrassing because what I was trying to do in this particular version of Newton was just to make a stable box. Like, that was the whole goal. It's literally just to make a box that doesn't implode on itself or whatever, right? And this was version probably like 500 of that attempt, because I really suck at math. And what kind of sucks, but what's also cool, is that when it first starts, the box seems to be stable, but then something happens to it. It's my favorite bug that I've ever created in any software ever. So all right, here we go. I'm gonna refresh it, and you'll see what happens if the internet works. Come on. Come on. There we go. All right, now watch. So I'm in a cafe scratching my head like, what the hell? Like, I couldn't build this if you asked me to, right? So, yeah, then that's the crazy part. It becomes a box, right? It stabilizes. It will never do that again, ever. It'll say that you can run it as long as you want. Trust me, I've tried. And it'll just keep on bouncing back and forth, back and forth. So what's really cool about this, right, is that because it's using a time buffer, I can refresh this as many times as I want, and every single time it will behave exactly the same way. There will be no difference, right? You could even compare the different frames, and they would be identical. And it doesn't matter what computer I ran it on. You can run this on an iPhone, and you can put it beside a computer, and it'll run at the exact same speed, right? And this is due to the combination of the game loop and the time buffer. So in this case, it lets me reproduce a bug, but it does other more useful things. I love this bug. It's, OK. All right, so I don't want to keep you guys too long. Let's put a little bit of this together. So that game that I showed you earlier, the one that looks like a really shitty version of Minecraft, this is the event loop for that game. I just copied and pasted it straight out, right? So it's not complicated. That's a full published game. You can finish it. It has music and audio and upgrades and everything. But like this is the full event loop, right? So it can keep things like tight and simple. And one of the nicest things that I think about an event loop is after building all sorts of sort of backbone spaghetti apps over the years, I love that an event loop lexically in code shows you like what you're doing over and over and over and over. It really like highlights the hot spots in your code for you. Usually if something's going wrong or going slow, it's because of something deep inside of your event loop. So here you can see the game loop, the time buffer, and the update method all working together, right? The whole function is the loop. This frame is just called over and over and over and over with a request animation frame. That time buffer is just the bit at the top. I wrote a little clock system that just implements a time buffer and does what I said. Adds time to it, and whenever it overflows a certain amount, it just extracts that amount out. Over and over and over, nothing special. And then you see a bunch of update methods here, right? It's updating controls, it's updating the player, it's updating the music, and like that's the whole thing. That's all you really need to make a game. And so where do you go next, right? I obviously just showed you the very, very basics of building a game, but I hope that some of you guys will go home and join one of these 48-hour competitions and try throwing something together. And these are some really good resources. If I were going to put together any game right now with JavaScript, these are the things that are simple, short, mature, fun, well-documented, right? That you can actually rely on to build things like 2D graphics, 3D graphics, and physics. You can use my company, Heroku, and the WS module in Node to build really awesome multiplayer stuff. And if you ever want to talk about any of this nerdy video game stuff with me, I'm Hunter Loftis on Twitter. I'm hunter@heroku.com. And I really appreciate everybody getting up this morning to come listen to all this game nerd stuff. So thank you.